Welcome to another OptaPlanner video. Today I'd like to show you how to leverage OptaPlanner Workbench to solve curriculum course scheduling problem. So let's start with a quick look at the problem definition and move to OptaPlanner configuration in the Workbench afterwards. So this is a real-world example that deals with scheduling of lectures at universities. The main idea of this problem is to assign those lectures into rooms with different capacities and to assign them into specific time periods. By period I mean fixed size time range at the day of the week, for example Friday from 9 to 10 AM. As for the other entities, we've got courses that the school offers, like mathematics and so on. Each course has a specific number of students who attend the course. There's always a teacher who teaches the course, but it's also possible for one teacher to teach multiple courses. Every course has one or multiple instances that I mentioned before, which are called lectures. And additionally there is a concept of curriculum, which is basically a set of courses of the same focus. So there can be, for example, a scientific curriculum, which would most likely include courses like physics and chemistry. On the other hand, humanities would probably offer courses like arts or history. So this is a constraint satisfaction problem, and there are multiple restrictions that we need to take into account. We call them hard and soft constraints. The hard constraints, which can't be broken by any means, are, for example, a teacher who can't teach two lectures at the same time. As for the soft constraints, they don't necessarily need to be met, however, they influence the quality of the solution. So there's, for example, a requirement to place the lectures of the same course into a single room. So that's for the problem definition. Now let's have a look at how to tweak the model using OptaPlanner annotations. At first we need to identify the object which changes its state during planning. In this case it will be the lecture, because we don't know in advance at which room and time period the lecture will be given. So those are the attributes that change over the time, and they are called planning variables. As you can see, there is also a planning solution object, which is called course schedule, which doesn't necessarily help in modeling the problem. However, it's used by OptaPlanner to reference all planning entities and other objects, so-called planning facts, that are used in the solving process. Alright, I've launched OptaPlanner Workbench locally, and now let's go through the configuration steps. So at first let's apply OptaPlanner annotations on selected data objects. I'll start with course schedule, which is so-called solution object or planning solution. I need to open the object editor and select planning solution. Let's use a hard soft score, which is a default value. Furthermore, I need to identify collections of planning entities and planning variables. So let's open lecture list first and check planning entity collection checkbox. And as for the planning variables, there are two related collections, period list and a room list. So I'll select a period list, I'll check planning value range provider checkbox and assign the range a unique ID. I'll reference the ID later in the planning entity. So for now let's name it period range here, and for room list let's call it room range. Okay, I can save the object now, and let's continue with the lecture, which is a planning entity. So once again I'm opening an object editor I'm selecting a planning entity here. By clicking on the source tab, I can see that the planning entity annotation has been added to the lecture. So let's leave the comparator definition for now and let's define planning variables first. So there are two planning variables, period and a room. I've got to check a planning variable checkbox here and insert range ID from the previous step. So it was period range, and for room it's room range. Okay, let's move to the solver configuration. As you can see, there's an enhanced termination editor which now supports definition of all termination types, including nasty terminations. In this example, I'll set the time spent termination to 1 minute, which basically tells the solver to stop after 1 minute. So let's erase this. And additionally, I'll select best score feasible termination, which stops the solver when it comes across a solution with no hard constraints broken. I'm using OR here just to make sure any of these two conditions will stop the solver once met. Okay, as the next step I can select a construction heuristic type in phase configuration. So there are multiple options here, and to use decreasing variations you need to define a difficulty comparator on the planning entity, which will basically say or decide which entities are more difficult to plan. So those can be, for example, lectures with a high number of attending students or the ones with multiple lectures. So for now, let's pick first fit decreasing, which will try to assign more difficult planning entities first in descending order. So I'm gonna save this. I'm opening the lecture once again, and I'm gonna check use difficulty comparator for sorting planning entities. And I'll add a new condition, student size. So this is one condition based on the number of students who attend the course, because such lectures are more difficult to plan. And let's add one more based on the number of lectures each course has. So that's it. I can save this, and that was pretty much it for the OptaPlanner specific configuration. And now I'd like to show you an example of creating a rule using guided rule editor. So as you can see, there are already some rules. I'm going to create a room capacity rule, which will basically decrease the score if the capacity of the room where a lecture takes place is exceeded. Okay, so let's go for it now. So let's create a new guided rule here. Let's call it room capacity. Alright. So here I'm matching all rooms. Let's bind it to a variable, and lectures where the room is equal to the room from the previous step, and additionally if the course student size is greater than the capacity of the room, then add a freeform DRL. So score holder add hard constraint match key context. Let's bind the student size to a variable. Okay. So room capacity minus student size, and that's it. So for the future versions, this will be polished, and there will be no need to specify custom Java code here. So just for the record, this decreases the hard part of the score by the number of students who exceeded the capacity of the room. So okay, let's save this. I've got the execution server running locally, and I've already deployed the application on it, and I've got some sample REST queries here. So this is a sample solution which is uninitialized. That means if we have a look at the lectures, their planning variables are not initialized. So the room and period attributes are empty here. So let's just submit this sample solution. Okay, so it was successful, and let's give it some time, and let's try to get the best solution. All right. Okay, and if we have a look at the list of lectures now, you can clearly see that the period and the room variables have been assigned to those lectures, so the planner basically solved this planning problem. And that's pretty much it. Yeah, that was an overview of using the Workbench to solve some more sophisticated scenarios. I mean, feel free to try it out yourself and leave a feedback. And don't forget to visit our website on OptaPlanner.org, where you can keep track of news and find useful links like issue tracker or IRC channels. Thank you.